Envision having a focal point the size of a world. Universes themselves can really serve as focal points. Stargazers all around the globe have been left scratching their heads as the James Webb Space Telescope identifies 6 new universes that shouldn't exist. With this telescope, astronomers and researchers can literally travel back into the past and see how galaxies formed billions of years ago. Yet, nobody was prepared for what they saw recently: 6 previously unseen galaxies that threaten to upend established cosmological theories. Researchers have declared that these discoveries are, in fact, impossible, defying established laws of science. What are these new galaxies? How did the James Webb Space Telescope find them? And what are the implications of these revelations? Join us as we explore how the James Webb Telescope identified a configuration that shouldn't exist. The study of the universe on its grandest scales, known as cosmology, is an exciting and ever-evolving field of inquiry. At the forefront of this vast exploration stands the James Webb Space Telescope, JWST, named after the cosmologist James E. Webb. It is the largest and most powerful space telescope ever built, with a primary mirror measuring 6.5 meters in diameter. This gigantic mirror, combined with its advanced infrared sensors, allows JWST to look back to the very origins of the universe, capturing light from the first galaxies that emerged just 250 million years after the Big Bang. The mission of the James Webb Space Telescope aims to transform our understanding of the universe, unraveling the mysteries of its evolution, shedding light on the formation of stars and galaxies, the development of large-scale structures, and the presence of potentially habitable exoplanets. The discovery of new galaxies is immensely significant in the realm of cosmology. Each newly discovered galaxy represents a piece of the vast puzzle, providing insights into the creation and evolution of the universe. By studying these distant galaxies, astronomers can gain insights into the formation of stars and planets, the distribution of dark matter and dark energy, and the overall structure of the universe. JWST's ability to detect faint, distant galaxies has already led to notable discoveries. In July 2022, the telescope captured images of galaxies that existed only 620 million years after the Big Bang, the farthest galaxies ever observed. What makes the James Webb Space Telescope unique? It is, indeed, the largest and most powerful space telescope ever constructed. It is an infrared telescope designed to detect light in the infrared portion of the electromagnetic spectrum. Its primary mirror, measuring 6.5 meters in diameter, is 3 times larger than the Hubble Space Telescope's mirror, allowing it to gather 3 times as much light and enabling it to see fainter and more distant objects. Furthermore, JWST operates at around -218 degrees Celsius, much colder than Hubble's -23 degrees Celsius, allowing its infrared detectors to work more effectively and be more sensitive to faint infrared light. The telescope is equipped with 4 scientific instruments, each designed to study different aspects of the universe as part of its mission to look back in time and observe the early nature and formation of galaxies, as well as to search for exoplanets. Recently, the James Webb Space Telescope has discovered 6 new galaxies that have captivated the attention of astronomers worldwide, providing astonishing glimpses into the earliest days of our universe. These cosmic systems, detailed in a new study based on JWST's first data release, appear as tiny red dots in the powerful telescope's images. By analyzing the light emitted by these galaxies, astronomers have established that they are witnessing them in the universe's early stages, just a short time after the Big Bang. While discovering such early galaxies is not surprising, the size and age of the stars within these galaxies are. Researchers expected the first star clusters to emerge shortly after the universe transitioned out of the era generally referred to as the Dark Ages, about the first 400 million years of its existence, when only a dense darkness of hydrogen molecules filled space. However, the galaxies identified in JWST's images appear remarkably large, with stars that are surprisingly old. According to experts, these new findings challenge existing theories about how the universe looked and evolved in its early years and do not match earlier observations made by Hubble. Julia, an assistant professor of cosmology and astronomy at Penn State and one of the study's authors, noted, we had specific assumptions for the types of galaxies that existed in the early universe. They are young and small. Previous studies of the early universe with various instruments tend to find small, blue baby galaxies, which had only recently formed from the primordial cosmic soup and were themselves building their first stars and structures. In general, young stars emit a brilliant blue light. However, in the ancient galaxies that JWST was designed to identify, astronomers did not expect to see old, red stars. They also did not anticipate discovering galaxies as massive as perhaps 1 billion suns. Yet, those red spots revealed in JWST's deep field images appear multiple times more massive than that. The most massive galaxies in their sample are estimated to have masses 2 to 3 times lower than that of our Milky Way. Researchers were subsequently astonished to find that some of these galaxy candidates are as large as our own galaxy when the universe was merely 3% of its current age. Leah expressed that previously, astronomers would need to rebuild cosmological theories to explain how these galaxies formed so rapidly after the Big Bang. They must ensure that the strange red spots they are observing are not something else. The majority of the alternative explanations, however, would also require completely new concepts. For example, stars in the early universe could emit light in unusual ways due to their lack of heavy elements, which may not be accounted for in current models. Alternatively, our understanding of how stars form locally, such as how many stars form from gas relative to their mass, might be fundamentally flawed when applied to the early universe. These things would likewise be energizing to find and would likewise topple how we might interpret star formation in the early universe, simply in a totally different way. He added, the most significant thing is that spectra give extremely exact distances to these items. According to the review, the distance and the character of these objects are connected. If we know the distance, we can nail down the identity, and vice versa. So a spectrum will pretty quickly let us know if our theories are right. These discoveries are as astonishing as they come, having researchers already challenged to change their speculations about the early universe. Just a tad north of a half year after the Webb team set the first perception free from the amazing observatory, Leah expressed that while the items so far do appear to be galaxies, there is a real possibility that some of the elements they found could be really gigantic black holes. Black holes are regions in space where a lot of matter is packed into an area, a huge number of times as large as the Sun, and where NASA says gravity is strong to the point that nothing, not even light, can escape. Yet, regardless of whether it turns out that some of the 6 objects they found are black holes, it still shows an amazing change, as indicated by specialists. Paying little mind to subsequent reporting, how much mass found shows that the known mass in stars at this time in our universe is based on 100 times more than researchers had previously thought. This suggests that massive galaxy formations started incredibly early in the history of the universe, adding to what many cosmologists had believed was settled science. According to the review, they have been casually calling these objects universe breakers, and they have been living up to their names so far. In a later statement made at Penn College, Leah said, "We explored the early universe for the first time, and had no clue what we were going to find. It turns out we tracked down something so startling that it actually makes issues for science. It calls the entire picture of early galaxy development into question." So what are these galaxies seen as somewhere down in the universe field, a region of the sky teeming with worlds? These newly discovered celestial bodies have become the marvel of stargazers as they challenge our understanding of galaxy formation and evolution. The first galaxy is a strikingly conservative and large one, designated GNZ11. It holds the qualification of being the most distant galaxy ever observed, its light traveling for more than 13 billion years to reach Earth at a time when the universe was only 330 million years old. Despite its early development, GNZ11 is surprisingly smaller, with a size akin to our Milky Way galaxy. However, in a stunning and perplexing twist, its mass is multiple times greater than that of the Milky Way, challenging everything we know about cosmic development. The second galaxy is named GNZ10 and is found roughly 13.3 billion light-years away. It displays a level of brilliance that is beyond what cosmologists expected to see, surpassing theoretical forecasts by almost 100 times. This has made cosmologists suggest that it might house a population of stars forming at an accelerated rate, potentially reshaping our understanding of early universe star formation processes. The third galaxy, GNZ 9, is located around 13 billion light-years from Earth. Like previously discovered ones, it also features plentiful heavy elements like oxygen, carbon, and nitrogen. These components, essential for life as we know it, were forged in the hearts of gigantic stars that exploded as supernovae, enriching the surrounding interstellar medium. The presence of heavy elements in this galaxy suggests that star development and supernovae were already happening in the early universe, a crucial stage toward the emergence of life. The fourth galaxy, designated GNZ 8, is situated around the same region as the previous one and has a strikingly organized disk, an aspect that challenges existing models of galaxy formation. Disks are thought to emerge from gravitational interactions within galaxies. However, the early universe was considered too tumultuous for such disks to form. The presence of this galaxy suggests that disk formation may have occurred sooner than previously thought, potentially altering how we understand galaxy evolution. The fifth galaxy, GZ7, is remarkably rich in dust, a component essential for planet formation. Dust particles are known to provide the building blocks for rocky planets, and their presence in this galaxy indicates that planetary systems may have begun forming in the early universe. The sixth and final galaxy, GNZ6, is strikingly different from the others, as it shows an astounding redshift, a measure of how much an object's light is stretched due to the expansion of the universe. This galaxy's redshift is slightly lower than anticipated for a system at its distance, proposing that it very well might be situated in a district of the universe with a somewhat slower extension rate. This perception could give significant bits of knowledge into the enormous scale design of the universe. The revelation of these 6 cosmic systems is a demonstration of the astounding abilities of the James Webb Space Telescope. Its strong infrared abilities permitted it to look through dust mists that darkened apparent light, revealing these far-off universes that had been hidden from our view. Researchers have credited the near-infrared camera for playing a vital role in these discoveries. Its high responsiveness and wide field of view empowered it to catch definite pictures of these weak, far-off systems. Additionally, its capacity to identify light in the near-infrared range permitted it to penetrate dust mists, giving a clearer perspective on these darkened objects. The discovery of these 6 worlds marks a significant jump forward in our understanding of the early universe. By concentrating on these far-off systems, astronomers can gain insights into the development of stars and galaxies, the advancement of large structures, and the presence of potentially livable exoplanets. This new discovery has challenged our understanding and speculations concerning how galaxies are shaped. One of the most critical ramifications of these revelations is that they suggest galaxies might have formed much sooner in the universe than previously thought. The James Webb Space Telescope has identified cosmic systems that existed only 300 million years after the Big Bang, challenging the overall view that galaxy formation began around 500 million years after the explosion. Furthermore, the discovery of galaxies with incredibly high stellar masses, such as GNZ 11, suggests that star formation in the early universe might have occurred much more rapidly than recently suspected. These massive systems formed within just a few hundred million years after the Big Bang, indicating that star formation processes were incredibly efficient in the early universe. Thirdly, the observation of galaxies with surprisingly organized disks, such as GNZ 8, challenges existing models of galaxy development. Disks are believed to emerge from gravitational interactions within galaxies, but the early universe was too turbulent for such disks to form. GNZ 8's presence suggests that disk formation may have happened sooner than previously thought, potentially modifying how we understand galaxy evolution. Additionally, the presence of heavy elements in galaxies like GNZ 9 indicates that supernova explosions of massive stars that produce heavy elements were occurring sooner than recently envisioned. This suggests that the chemical evolution of the universe might have progressed more quickly than previously understood, possibly affecting the formation of planets and the chance of early life. Ultimately, finding these early systems has required modifications to existing cosmological models. These models need to account for the earlier formation of galaxies, the accelerated star formation rates, and the presence of heavy elements in the early universe. These observations have pushed us to reconsider our current theories and models, leading to a deeper and more comprehensive understanding of the universe. As new and more powerful telescopes come online, we can anticipate even more momentous discoveries that will continue to shape our cosmological frameworks. However, these new discoveries of galaxies have sweeping implications for future space missions and cosmological investigations. They have opened up new avenues of research and highlighted the need for more powerful and sophisticated telescopes to probe the depths of the universe. The discovery of galaxies in the early universe provides a unique opportunity to study galaxy formation and evolution in its infancy. By observing these distant worlds, cosmologists can gain insights into the initial states of the universe, the processes that led to the formation of the first galaxies, and how these galaxies have evolved over billions of years. The James Webb Space Telescope has played a crucial role in these discoveries, and future space missions are expected to build upon its success. The Vera C. Rubin Observatory, scheduled to begin operations in 2024, will provide a comprehensive survey of the sky, allowing astronomers to identify and study numerous galaxies, including distant ones like those recently found. The discovery of galaxies with high stellar masses and organized disks suggests that dark matter can also play a more complex role in galaxy formation. Additionally, the presence of galaxies in regions with somewhat slower expansion rates might provide new insights into the nature of dark energy. With telescopes like the James Webb Space Telescope and the upcoming Large Synoptic Survey Telescope, astronomers could study dark matter and dark energy in more detail. These missions will provide accurate measurements of the distribution of galaxies and the expansion of the universe, helping to refine our understanding of these mysterious components of the universe. Moreover, the discovery of dust and galaxies like GNZ7 demonstrates that planetary systems may have begun forming in the early universe, raising the possibility that habitable exoplanets might exist in these distant systems. Ultimately, the revelations of these early systems have highlighted the interconnectedness of various areas of cosmology. By focusing on galaxy formation and evolution, we gain insights into the behavior of dark matter and dark energy, the chemical evolution of the universe, and the potential for life beyond Earth. This will require that future cosmological investigations endeavor to unify these various areas, fostering a comprehensive understanding of the universe from its earliest moments to its current state. This will necessitate collaboration between cosmologists, physicists, and other scientists, driving deeper curiosity about the universe's vastness and complexity. With these revelations, and many more expected to follow in the near future, researchers and astronomers may find themselves revisiting established ideas and theories about the universe and how it operates, which, in fact, would not be a bad thing.